All right, strap yourselves in because we are taking a deep dive today into NASA's Parker Solar Probe.
Oh, exciting.
This thing is going to get closer to the sun than any other spacecraft has ever even attempted. Can you believe it?
I mean, that's pretty wild.
Talk about a front row seat to some seriously intense solar action. And thankfully, we have a fascinating article here to help guide our deep dive today.
Yeah.
It's even aptly titled, NASA's Parker Solar Probe dares to dance with the sun.
It's a good one.
It really is.
I mean, it really is remarkable.
Yeah.
Not just from like an engineering standpoint, but like you said, what it's going to show us, what it's going to reveal about the sun.
Absolutely. It's really going to, answer some hopefully long-standing questions about the sun.
Yeah.
So, okay, let's start with the basics, I guess. I mean, this mission isn't just about getting close to the sun just for the thrill of it, right?
Right.
I mean, there's got to be a bigger purpose here.
Oh, absolutely.
What's the point? What are we hoping to learn from this?
Yeah, what are we trying to get out of the Parker Solar Probe?
Yeah.
So this probe is designed to answer some like fundamental questions about the sun.
Okay.
Like how is the solar wind generated? And how does the corona, that outer layer of the sun's atmosphere, how does that get heated to millions of degrees?
Millions.
It's crazy.
Yeah.
And it's been a puzzle that has baffled scientists for decades.
Really?
Oh, yeah.
Wow.
Like a big one. It's a head scratcher.
So, okay, like why should we care about solar wind,
Yeah.
superheated coronas? Like what's the connection to us here on Earth? Why does it matter?
You got to remember, I mean, the sun is like the powerhouse of our solar system, right?
Right.
So its activity, it directly impacts us here on Earth, sometimes in some pretty dramatic ways,
Yeah.
Like, remember that massive solar storm back in 1859?
Vaguely.
Refresh my memory.
Yeah, give me the details.
Okay, so this was called the Carrington event, and it fried telegraph systems
Oh, wow.
all over the world.
Really?
Imagine that happening today
Oh, God.
with our reliance on, like, GPS and communication networks, power grids.
It'd be chaos.
It would be absolute chaos.
Yeah.
So,
Okay, now you've got my attention.
right. It's a big deal.
So the Parker Solar Probe is going to give us crucial information to kind of help us understand and maybe even predict these events.
Exactly.
These potentially catastrophic events.
Exactly. Yeah. The data it gathers is going to help us build better models of solar activity.
Okay.
So we can forecast these solar storms and hopefully mitigate their impact,
Right.
on our technology and our infrastructure and just, us in general.
Right. So it's not just like we're going and looking at the sun just because we're curious.
Right.
We're doing this for our own safety and well-being here on Earth.
Exactly. Yeah.
It's fascinating to think about
It is.
that connection.
It really is a testament to how science and exploration can have very real and tangible benefits for us,
Yeah, for humanity, absolutely.
Yeah.
This is really changing the way I think about the sun
Well,
already, just from like the first few minutes of this deep dive.
okay.
Okay, so now I understand that the probe is currently on track for its closest approach to the sun.
It is.
And this is happening on Christmas Eve, right?
It is. Yeah.
Talk about a dramatic timeline.
It really adds to the suspense.
It really does.
Yeah. So on December 24th, the Parker Solar Probe will be a mere 3.8 million miles from the sun's surface.
So 3.8 million miles, I mean, that still sounds pretty far to me. Like, why is that considered so close?
It's all relative.
Okay.
3.8 million miles puts the Parker Solar Probe within the sun's corona, so that superheated outer atmosphere that we were talking about. It's an environment so extreme that no human-made object has ever ventured into it before.
So we're talking uncharted territory here.
Uncharted territory.
Okay, now that puts things into perspective a little bit.
Right.
So the Parker Solar Probe is literally like diving headfirst into the unknown.
It is, and it's doing so while traveling at incredible speeds, over 430,000 miles per hour, to be precise.
Hold on, did you say 430,000 miles an hour?
That's right.
That's practically unimaginable.
I know.
I mean, can you even put that speed into context for me?
Well, imagine traveling from New York to Los Angeles in less than a minute.
Wow.
That's the kind of velocity we're talking about.
Okay, I'm starting to grasp the audacity of this mission, like really starting to understand what's going on here.
Right.
But I mean, at those speeds and in that kind of heat, that kind of environment, I mean, how can it even survive?
Right.
Let alone collect data.
Yeah. How does it not just melt?
Right, exactly.
Well, that's where the brilliance of the engineering comes in.
Okay.
So The probe is equipped with a revolutionary heat shield
Okay.
made of a carbon composite material, and this shield can withstand temperatures exceeding 2,500 degrees Fahrenheit.
That's hot enough to melt steel.
I know, it's wild.
This sounds like something out of science fiction.
It does, doesn't it?
Yeah, it does.
But it's very real. And it's what allows the Parker Solar Probe to operate in such an extreme environment.
So behind that shield, the spacecraft itself is what, just chilling?
Pretty much.
Yeah.
It stays at a comfortable room temperature,
Wow.
protecting all the sensitive instruments on board.
Speaking of instruments, what kind of data is the Parker Solar Probe actually collecting? I mean, as it's, hurtling towards the sun.
Right, so it's equipped with a suite of instruments designed to study various aspects of the sun.
Yeah.
One of them is called fields,
Okay.
and it measures the electric and magnetic fields around the sun.
Okay.
This is crucial because those fluctuating magnetic fields are what drive those spectacular solar flares that we see, those big eruptions.
So Fields is essentially giving us like a front row seat to the dynamics of those massive solar eruptions.
Exactly. And then there's another instrument, it's called WHISPER,
Okay.
which stands for Wide Field Imager for Solar Probe.
Catchy.
No, right?
Yeah.
So this one is capturing images of the solar wind as it streams away from the sun.
Oh, wow.
So we can actually see it.
It's incredible to think that we have this little probe out there braving these conditions and collecting all this data that's really changing our understanding of the sun.
It really is a testament to human ingenuity and our desire to explore the universe around us.
Absolutely.
That's for sure.
Okay, so we've got this incredibly sophisticated spacecraft, right?
Yeah.
On this perilous journey, traveling at, just these mind-blowing speeds, equipped with all this technology, this cutting-edge technology,
Right.
to study the sun up close and personal.
Right.
But here's the kicker.
Okay.
During its closest approach, on Christmas Eve,
Yeah.
we're going to lose contact with the probe completely.
Yeah. Yeah, there will be a communication blackout for a few days.
What?
Yeah. Due to all the solar interference. It's like the probe is venturing into this realm where our usual methods of communication, they just don't work.
So we're all just holding our breath, waiting for it to emerge from the other side of this blackout.
Right.
What happens next?
So we wait for a signal,
Okay.
a beacon from the probe,
Okay.
confirming that it survived this closest approach.
Hmm.
And that signal is expected on December 27th.
December 27th. Mark your calendars, folks.
That's the day.
That's when we find out if this thing made it
Big day.
through its dance with the sun.
It is.
I can't wait to hear what it has to tell us.
I know, it's going to be an anxious wait.
Yeah.
But the potential payoff is, it's huge.
Yeah.
The data collected during this closest approach
Yeah.
could unlock some of the biggest secrets about the sun
Wow.
and its impact on our world.
Yeah. Incredible.
Welcome back.
It's definitely getting exciting now as we're getting closer and closer to that beacon signal from the Parker Solar Probe. It really is. I'm kind of on the edge of my seat, just picturing this little probe hurtling around the sun, gathering all this amazing information.
Yeah.
It's times like these I wish I'd paid a little more attention in physics class.
You and me both.
But
Luckily, we have the expertise of the brilliant minds at NASA to kind of guide us through all of this.
right.
But speaking of the probe's data collection, what are we going to do with all this information?
Yeah.
Once we get it back?
Yeah, that's a great question.
It's one thing to have all this raw data about the sun.
Right.
But how do we actually make sense of it all?
Yeah, how do we take all that and make it digestible, make it useful?
Yeah, so that's where the real work begins.
Okay.
Think of it like this. So the Parker Solar Probe is kind of like this intrepid explorer
Okay.
venturing into this uncharted territory
Okay.
and bringing back samples of the sun's energy, magnetism, and atmosphere.
I like that. I like that analogy. Yeah, so what do we do with those samples then?
So scientists around the world are going to be analyzing this data,
Okay.
looking for patterns and anomalies and insights that can help answer those fundamental questions we talked about earlier.
Right.
How is the solar wind generated?
Yeah.
What heats the corona to millions of degrees?
Yeah.
And how do these things impact us on Earth?
So it's a huge collaborative effort then to kind of piece together this puzzle.
Absolutely.
Okay, so are there any initial findings from the Parker Solar Probe? Has anything surprised scientists so far?
There have been quite a few surprises, actually.
Really?
one of the most unexpected discoveries was the presence of these things called switchbacks in the solar wind.
Switchbacks?
Yeah. So imagine the solar wind, like a smooth, continuous flow of charged particles.
Okay. Okay, like a steady breeze almost.
Exactly, like a steady breeze.
Okay.
But the Parker Solar Probe is finding that the solar wind is anything but steady.
Hmm.
It's full of these sudden, rapid reversals in magnetic field direction.
So like zigzags in the wind.
Exactly, like zigzags in the wind, yeah.
Switchbacks, huh? So that sounds pretty dramatic.
It is dramatic.
Like what causes them? What's going on there?
So that's one of the big mysteries scientists are trying to solve.
Okay.
They think these switchbacks might be linked to the way that the sun's magnetic field interacts with the solar wind.
Oh, okay.
But more data is needed to confirm that for sure.
Okay, so we're already kind of like, shaking up our understanding of the solar wind.
Right.
What about the corona, that superheated outer atmosphere? Any new insights there?
Yes. In fact, the probe has found evidence of a dust-free zone close to the sun.
A dust-free zone? What does that even mean?
So you would expect that as you get closer to the sun, the amount of dust would increase, right?
Yeah, I mean, yeah. More dust, closer to the source.
Right, exactly.
That's it.
But the Parker Solar Probe found the opposite. As it got closer to the sun, the amount of dust actually decreased, creating a zone that's almost entirely devoid of these dust particles.
That's really strange.
It is.
Like, what's the explanation for that?
Scientists believe that the intense heat and radiation from the sun are vaporizing the dust particles, creating this unexpected dust-free zone.
So the Parker Solar Probe is really revealing all sorts of unexpected phenomena.
Yes.
I mean, it's really rewriting our understanding of the sun with each pass.
Yeah, each close approach.
This is groundbreaking stuff.
It is, and remember, this is just the tip of the iceberg.
Wow.
We're only beginning to analyze the data from the probe's previous encounters. Like, imagine the wealth of information we're going to have once this latest close approach is complete.
It's just mind-boggling to think about the sheer amount of data that this mission is generating.
It is.
But it's not just about collecting the data, is it?
No.
It's about using this data to solve real-world problems.
Right. Absolutely predicting and mitigating the impact of solar storms.
Absolutely, yeah.
Okay, so the Parker Solar Probe is part of NASA's Living with a Star program.
That's right.
Right.
Yeah.
You mentioned this earlier.
Yeah.
I'd love to hear a little bit more about it. Like, what's the overall goal?
Yeah, so the Living with the Star program, it recognizes that the sun is both a life giver and a potential threat.
Okay.
It provides the energy that sustains life on Earth.
Right.
But its eruptions can also disrupt our technology and our communications, even our power grids.
Right. Back to that Carrington event.
Exactly.
That we talked about.
Yeah, so the goal of this program is to develop a deeper understanding of the sun.
Okay.
So we can better predict these events and protect ourselves from their potentially devastating consequences.
So it's about taking a proactive approach to space weather.
Exactly.
Recognizing that what happens on the sun directly affects us here on Earth.
Absolutely. Yeah.
Okay.
The Parker Solar Probe is a crucial piece of this puzzle.
It's providing us with the data we need to forecast these solar storms and develop these mitigation strategies.
Okay, so the Parker Solar Probe is not just about scientific discovery.
Right.
It's about safeguarding our technological civilization.
Exactly.
That's what I call a mission with a purpose.
Couldn't have said it better myself.
It's a perfect example of how, space exploration can have tangible benefits for us here,
Right.
for humanity right here on Earth,
Yeah.
while expanding our understanding of the universe.
For sure.
It's incredible to think that we're living in a time where we can send a spacecraft to literally touch the sun
Right.
and use that information to protect our planet.
It really is a testament to human ingenuity.
Yeah.
And our spirit of exploration.
All right, so we've covered a lot of ground here.
We have.
We've talked about the Parker Solar Probe's mission, its, just daring journey, the groundbreaking discoveries that it's already made.
It's been busy.
It has been busy.
All there. And the potential benefits for humanity. Absolutely. I mean, this is incredible stuff. It is. It's been quite a journey so far, and we're not done yet. Yeah. The probe is about to make its closest approach to the sun, venturing into this region where no human-made object has ever been before.
And we're all eagerly awaiting that beacon signal, hoping to hear that the Parker Solar Probe has survived its dance with the sun.
Fingers crossed.
What happens after that? What are the next steps in this incredible mission?
Right. So
I feel like we've only just begun to sort of explore this whole mission, and I'm blown away
right.
by the ingenuity and just the scientific ambition here.
I know, and we're just getting started.
I know.
The data from this closest approach is going to keep scientists busy
Yeah.
for years to come.
Really?
Oh, yeah.
Wow.
Think about it. We'll be peering into the very heart of the sun's activity,
Hmm.
getting insights into the processes that drive space weather and influence our planet.
It really highlights how connected we are to the cosmos, you know?
Yeah,
What happens out there really
Yeah.
does affect us here.
it does.
Who would have thought that a mission to study the sun
Yeah.
would be so crucial for protecting our way of life and our technology?
Right, exactly.
So what happens after the Parker Solar Probe phones home, so to speak? I
Yeah.
mean, what's next? What's on the agenda?
So the mission isn't over after this close encounter.
Oh.
In fact, the Parker Solar Probe is scheduled to continue its mission for several more years.
Several more years. I thought this was it.
I know, right? It seems like this big, huge finale.
Yeah.
But it's not.
Right.
This is just one of many planned, close approaches.
Oh, really?
Yeah, so the probe's orbit is designed to bring it closer and closer
Okay.
to the sun over time.
So each time it goes around, it's
Yeah.
gathering more information,
More data.
getting closer, braving even more extreme conditions.
Okay.
That's wild.
I know.
This mission is already a testament to human innovation.
Yeah.
But knowing that it's going to continue for years to come,
Right.
collecting even more data,
Yeah.
what kind of long-term impact do you think this is going to have on our understanding of the sun?
Yeah, it's hard to overstate the potential impact.
Really?
Yeah.
Yeah.
So the Parker Solar Probe is already rewriting the textbooks on the sun, challenging our assumptions and providing these new insights into fundamental processes.
So it's almost like we've been looking at the sun through this blurry lens for centuries,
Yeah.
and we're finally getting a clear picture.
That's a great analogy.
Yeah.
The data from this mission is giving us a much sharper, more detailed view of the sun than
Yeah.
we've ever had before.
Right.
And that's going to have ripple effects across multiple fields,
Oh, wow.
from astrophysics to space weather forecasting.
I bet this data is going to be a gold mine
Oh, absolutely.
for scientists for generations to come.
Yes. It's really laying the groundwork for a whole new era of solar science.
It makes you wonder, like, what other seemingly impossible feats we
Right.
might accomplish in the years to come.
Yeah, like maybe someday we'll be talking about sending a spacecraft to another star system,
Yeah.
building on the knowledge and technology pioneered by the Parker Solar Probe.
I mean, that's incredible.
That is a thought-provoking idea.
The Parker Solar Probe is really proving that we are capable of incredible things.
Yeah,
When we really set our minds to it, who knows what the future holds.
exactly. The sky's the limit.
Well, folks, I think we've reached the end of our deep dive into the Parker Solar Probe.
Yeah, we've covered a lot.
It's been an incredible journey exploring the cutting-edge science and the audacious engineering,
It has.
and just the profound implications of this mission.
I know. It's been a pleasure sharing this exploration with you.
Likewise.
That's for sure.
Before we sign off, I just want to leave our listeners with a final thought. We've talked about the Parker Solar Probe's mission to study the sun, but I really think it's also a mission that reflects humanity's desire
Yeah.
to explore, to understand,
Push the boundaries.
and to push the boundaries of what's possible.
Absolutely.
So the next time you look up at the sun, remember that little probe out there,
Yeah.
dancing closer than anything we've ever sent before?
Amazing.
It's a symbol of human ambition.
It is.
A beacon of scientific progress, and a reminder that even the most distant stars
Yeah.
can hold clues to understanding our own planet and our place in the cosmos.
Beautifully said.
Thanks for joining us.
It's been fun.